Let's now see if we can use integration by parts to take the antiderivative of e to the x cosine of x dx. And this one's an interesting one, and you'll see why in a few minutes. Because here, if I take the derivative of either of these, it doesn't get appreciably more simple or appreciably more complicated if I were to take its antiderivative. The derivative of e to the x is e to the x. The antiderivative of e to the x is e to the x. Derivative of cosine of x is negative sine of x. Antiderivative of cosine of x is sine of x. So it seems to be about comparable. And because of that, we can essentially, let's just arbitrarily assign one of these to be f of x and the other one to be g prime of x. Neither one of them simplifies dramatically or gets more complicated when I take the derivative or the antiderivative. So let's say that f of x is equal to e to the x, and let's set g prime of x to be equal to cosine of x. So given that, we can write over here that f of x is equal to e to the x, f prime of x is equal to e to the x. We can write that g prime of x, the derivative of g, is equal to cosine of x. And then the antiderivative, g of x, could just be equal to sine of x. So let's apply integration by parts. This whole thing will simplify to, this will be equal to f of x times g of x. So this is e to the x times sine of x times sine of x minus the antiderivative of f prime of x. Well, f prime of x is e to the x. So it's going to be e to the x times g of x times sine of x. So once again, this doesn't look like we've gotten, obviously, any more simple so far. This antiderivative situation is about as hard as this one right over here. But let's keep going to see if something interesting might happen. You might guess what might happen. So let's see how we can evaluate. Whoops, I wanted to select that. Let's think about how we can evaluate this thing here. So let me copy and paste it. So copy and paste. So let's evaluate. Let's try to evaluate this thing right over here. And similarly, we can do it using integration by parts. So now let's set f of x, once again, equaling e to the x. So f of x is equal to e to the x, just like we did before. F prime of x is equal to e to the x. We could set g prime of x. G prime of x is equal to sine of x. Then g of x, the antiderivative of sine of x, is negative cosine of x. Now let's apply integration by parts again. So this thing over here, remember, this is what we're evaluating. This is what we're evaluating now. We're doing a second round of integration by parts. This is what we're evaluating. This is equal to f of x times g of x. F of x is e to the x. It's e to the x. Well, we have a negative out here, so I'll write negative e to the x cosine of x. And we got the negative from the g of x. I'll put that in pink as well. And then we have minus the antiderivative of f prime of x. F prime of x is e to the x, g of x. G of x is negative cosine of x. So we could put the cosine of x over here, and then take the negative out of the integral, and so this could become a positive. It was subtracting negative cosine, or subtracting this integral which had a negative in it. I just took the negative out. This became a positive dx. So you might say, hey, Sal, it looks like we're going in circles. Once again, we have another integral that was no less complicated than this one, and it's actually got us back to where we were in the beginning. But this is interesting. What if we assigned a variable to this thing that we had in the beginning? I don't know, let's call that a. Let's call this thing a. A is equal to this business right over here. So now we can say that a is equal to this business, which is equal to e to the x sine of x, now I want to do that same pink color, sine of x, and I'm just using a to simplify the notation a little bit, e to the x sine of x minus this business, which we just figured out was negative e to the x cosine of x. So negative e to the x cosine of x, e to the x cosine of x, cosine of x. And then this right over here is our a again. A was defined as the antiderivative of e to the x cosine of x. So this right over here is our a again. So we could put a plus a, just like that. And now let's see if we could solve for a, because a is what we cared about. So let's see what we can do. A is equal to e to the x sine of x, and then distribute the negative. So it's going to be plus e to the x cosine of x, e to the x cosine of x, and then minus a. I'll do the a in blue, minus a. I just distributed this negative sign. Now, if we want to solve for a, we could just add a to both sides to get all the a's on the left-hand side. And then we are left with 2a is equal to this business, which I can just copy and paste. 2a is equal to that. So let me copy and paste that. 2a is equal to that. Or a, which is what we cared about in the beginning, a is equal to, and now we definitely deserve a drum roll, a is equal to all of that business, all of this business, divided by 2. We're just solving for a is equal to all of that business divided by 2. And remember, a is just what we wanted to solve in the beginning. A is equal to the antiderivative of e to the x cosine of x dx. And we're done. We were able to use integration by parts twice to come around full circle to get back to our original expression. But then we solved for that original expression. We had an equation in terms of that original expression. I just set a to be equal to it, so I didn't have to rewrite it over and over again. But we have our original expression. The antiderivative of e to the x cosine of x is equal to all of this business, which is kind of a neat expression right here. It has a kind of a beauty to it. It has an e to the x. It's got sine of x plus cosine of x. You're taking somehow the average of these two things. It seems kind of just like a neat thing.